So let's begin by discussing what a quantum network is and how it differs from a classical network. We in the quantum networking community, we use the term classical network for every type of network that's not a quantum network. Pretty much every network that you've ever worked with, including the internet or the Wi-Fi network in your home, is an example of such a classical network. Classical networks send classical bits, which are just ones and zeros, and they're typically encoded as light pulses in optical fibers or as radio pulses sent through the air. Quantum networks, on the other hand, communicate using quantum bits, which are also known as qubits. These quantum bits have special properties that are described by the laws of quantum physics. One of the most famous of such properties is called superposition, which is often and slightly incorrectly described as a qubit being both a 1 and a 0 at the same time. And another famous property is called entanglement, where the fate of two qubits is connected even if they are very far apart from each other. But there's many other quantum properties that make quantum networks special. Now, in this seminar, I'm not going to get into the details of quantum physics, but the only thing that is important to remember is that these special quantum properties allow quantum networks to do certain things that are impossible or very difficult to do with classical networks. On the other side, quantum networks also have unique limitations that are very different from the limitations of classical networks. So in this seminar, my goal is to show you that classical networks and quantum networks each have their own strengths and weaknesses, and by combining quantum networks with classical networks, we can get the best of both worlds.